Just make sure. Yep. It's good, working? We're live? Okay. Hi, everyone. My name is Aly Ibrahim. I'm a solutions architect at Microsoft. I know in the agenda it's showing Amazon, but I left Amazon. So currently, I'm with Microsoft. So today we're speaking about API management, and it's a topic that you may not think it's fit for the cloud. You may not think it's fit for the developers, but it fits for both. So quick intro. As I mentioned, I'm Aly Ibrahim. I'm currently working as a technology specialist, a fancy name for a solutions architect. So my background is in development. I moved into DevOps, system admin, and I worked in cloud since 2016, 2015, something like that. My most domains, as I mentioned, I work also in Kubernetes, serverless architectures, and GitOps. I like to simplify things for developers because I'm originally a developer. So that's why I picked that topic and want to speak about. So before we start and to level set, let's speak what is an API first. So APIs, as per definition from IBM and maybe from Postman, it's a set of protocols that enable different software components to communicate and transfer data. So very fancy description that probably didn't understand anything of. So the acronym API is shorthand for Application Programming Interface. In a shorthand, it's kind of a contract. It's a contract between the developers and the developers, but both on the different side of the spectrum. So we have a developer who is providing services and a developer who's consuming that service. And the contract is made to transfer data. So how the consumer developer can expect the data to come and how to ask for it, how to request the data, and how to expect the data to be presented to them. So some of the examples, you can think of commercial APIs, like if you go to Best Buy, for example, or like you were just finished the Black Friday sales. So if you want to buy anything, those are sent as APIs to the service providers from the back end. Of course, you're interacting with the front end, but on the back end, the front end is sending the API, a request to the service provider to request whatever, like listing, show me all the laptops that you have on Amazon, maybe show me, give me the best deals you have, something like that. So those are all APIs. You can think also of social media as some kind of APIs. And this is like that evolved from the early 2000s when like Facebook started to come and Twitter and all these things. If you're watching a post, if you're scrolling your news feed, or if you're posting or commenting, all these are APIs sent to the back end of Facebook or of Twitter or of anything like that. We have also other APIs that deals with data, especially if you're having now like Ring and all the IoT devices and metering devices and all these things. They are all sending data every time. And to consume these data also on your when you're paying your bills or something like that, you can see the chart of your data. This is also going as an API to the back end and receiving that. And one of the very famous APIs are the cloud APIs. So if you're dealing with AWS or Azure or anything like that, when you request an S3, for example, when you go and create a Lambda, or when you create a virtual machine, this is an API that goes to the provider, or like Amazon or Azure or anything like that, and they get the data out of this API call, the request, understand what you want. Maybe you want a virtual machine with 16 gigs of RAM and 4 cores, and try to provision that on the back end. But with those APIs, you can face some challenges. If you're the one who's providing the APIs, if you're the API provider, you can face challenges creating your APIs. So one of these challenges are authentication and authorization, and combine both together. So you don't want to provide your APIs to everyone, and anyone can access it. Like, for example, let's take again the cloud example that we mentioned. If you're working on Azure, you need to subscribe first to Azure, and you get an ID, a user ID, and this is where you can speak to Azure and request, because you cannot request a very big resources. Otherwise, Azure will block you because you don't have access. So, okay, they know that you are the user, and this is the authentication part. But they know also, because this user is on the free tier, he doesn't have access to maybe 500 GB machines. Or on AWS, for example, you have access to the resources, but you cannot expand it beyond this limit. So that's authorization. So first, we need to know who you are when you log in. Second thing, we need to know what you're able to do, and that's with authorization. And those things, the API itself should take care of, like the back end of the API. Another challenge is caching. How many of you are front developers here? Front-end developers? Okay, so probably we're dealing with Redux and some caching. You don't want every request to go to the back end and fetch the data from the database because there are latencies. So to go and get the data, there are some latencies. And sometimes for the user experience, it's better to be fast. And instead of going back, you just cache the data if it's something that doesn't change frequently. And you can respond back from that cache. So that caching you need to manage, whether with Redux, if you're putting that into an application on the cloud, or even on-prem, you need to set up your maybe Redux cache or Elasticache or something like that to handle this caching. One of the other challenges is security. So now you have your API. Your APIs, once it's public, you can face some kind of DDoS attacks. Like people can just throw your APIs with lots of requests until your servers are down and couldn't respond back to your response to the requesters. How do you handle that? You can, of course, there are ways to do that through WAFs or through maybe circuit breakers or something, some conditions on the development side from the back end. Another thing is falling back. Like if your server are getting overwhelmed with requests, what are the fallback strategy? Where do you want to divert your request instead of sending 404 to all your requests? The other thing is versioning. If we're providing an API now with specific API spec, which is the contract that we spoke about, the API may be, let's take an example from the social media. You're requesting your friend list, and it's showing you on the friend list maybe the name, maybe the birthday, and something else. Maybe later you decided to add also pictures. So this is an addition to the API. So now the API is responding with something else. But what about the initial consumers? They didn't code their code to accept pictures. Or maybe on the worst case that they removed one of the fields. So now the developers who are using version 1 are now will break. The requests will break. So how do you handle versioning? And you want to keep version 1, version 2, multiple versions of your API. Another challenge is monetization, and that should be very helpful and should be in all of our minds. How to monetize your services, especially as small companies and developers, and you want to monetize. Like the big companies are already monetizing, but if you want to monetize your APIs, you're providing services, and you want to make revenue out of that. So how do you manage who's using what? You want to put some tiers to your APIs, like maybe a free tier, like we mentioned, maybe a basic tier, maybe a pro tier that can consume 200 requests per second, per second, or a basic tier that only limited to 10 requests per second. So those are some challenges, and to come over those challenges, we have API management. So we have front end, and we have the back end, and we need a layer between to manage those APIs. So the definition of the API management is the practice of establishing efficient, standardized process for working with APIs. Again, very fancy name, but the main idea is an intermediator between the front end and the back end, and that intermediator has policies that can define how you interact with your APIs on the back end. The main components of API management are usually 3. So we have the developer portal, and that's some of the services, and we'll speak later about the services that provide API management. Some of the services have developer portals. Some of the services, they don't provide it for you, but they let you develop your own portal. So this is optional. The 2 main components are the management portals and the gateway. The management portal is how you configure your backends. This is where you register your APIs to the management This is how you can define policies, like how define your tiers. What are the maybe the basic tier, the pro tier, what are the requirements for each tier, and how do you want to implement policies? And we'll speak about the policies on the next slide. In the management portal also this is where you can manage your users, manage your groups, do the connection between your API management and the backends, all your backends, whether your backends are servers consuming your stuff, or maybe functions, Azure functions or Lambda functions, or maybe containers. You need to link and let the API management know what are your backends. And the third component, which is the most important one, is the gateway. The management portal, you put all the configuration, but it needs to provision those configuration into the gateway. And the gateway is the component that receives the requests. So it has to know, okay, if I'm receiving the request from this user, what should I do? If there are policies applied into that, to this API, how can I execute those policies? How can I generate maybe blockage? How can I do transformations of the requests? We spoke about caching, like how can I do caching? All this is done through the gateway. So the gateway is like the mind of the API management. The management portal is just how you configure that mind to make it do what you're looking for. Any questions so far? Okay, cool. So we spoke about policies, and we mentioned like from the management portal, you can create some policies and manage those policies, let the gateway manage those policies. So what are policies? Policies are just statements that you configure your gateway to do. Some of those policies could be related to flow control. So for example, we just speak about versioning, one of the challenges. So maybe you have your API version 1 and version 2, and from the URL, the gateway will understand that v1 will be sent to backend number 1, version 2 will be sent to backend version 2. So it's seamless from the front end. They don't need to specify where to go or different URLs, but the API management in between can do the flow control of those codes. Can also do, some policies can do some verifications. So maybe before sending to your backend and consuming all your resources, maybe you just want to confirm that there is a header for the API key. If there is no header, don't even send to the backend. So we're removing that. Maybe you want to make sure that in the request, there is a name field in the body. If that is not available, don't send the request, and maybe just respond directly. So the gateway will respond directly without going to your backend and consuming your resources. We spoke about authentication and authorization. That could be through like a JWT tokens. And the gateway itself can be configured to connect to an authentication service like Okta or any cloud authentication service, and it will do this authorization authentication on your behalf. So you offload this to other service. Instead of you code all these things, you offload it to the gateway so it can do this authentication authorization for you. Caching, we speak about caching. The gateway itself can do caching, so it can, instead of sending all the requests back to the backend, it understand that, okay, there is a 30 seconds cache, so all the requests coming within that 30 seconds will not go back to your backend. It will get to the gateway, and the gateway will understand, okay, well, I have cache for this set up for 30 seconds, so I'll just respond back from my cache without going to the backend. So it's reducing the load on your backend and making the communication even faster because it doesn't need to go further than that. There are also other policies that can do transformations. For example, transforming from XML to JSON or from JSON to XML, and any other transformation, maybe just replace this header with the key, something like that. So in that case, the flow will be like that. Instead of going directly from the user or from the developer or from the UI directly to the API, everything will pass through the API gateway, and the API gateway will do some logic and analyze the request. If it's valid, verified, we have the right authentication, it will send it to the API, the backends, and on the going back from the API to the user, it can also, there are policies also that can be transformed on the other side, like maybe responding with JSON, the API, and there is a policy to respond in XML, so it will do the transformation, or it add back another header to the user to consume it. Okay, so this is all good. There are lots of API management tools that I worked with, and they're available. MuleSoft is very famous. 3Scale is one famous one. And there are also cloud versions. So we're speaking about the cloud. This is the cloud track. So why do you need to do that in the cloud? So first of all, you don't need to buy the API management as a solution. You can just pay as use. As much as you add and configure and provision APIs, this is what you pay for. Most of them has very generous free tier, so you can consume it for free, especially for your side projects. You don't need to pay for anything. Second reason is it's native integrated with other cloud services. We were just speaking about authentication and authorization. So if you're using AWS, there's something called Cognito that can handle the authentication and authorization. If you're using Azure, Active Directory can handle authentication and authorization. And it's seamless integrated. Like you don't need to write any code to do the integration between your API management and it. We just spoke about Redis and caching. So you don't need to go and implement that yourself. It can auto-scale. If there are lots of requests coming, you don't need to handle the management. And it upgrades auto for you. So you don't need to manage any of that. That's one of the reasons the cloud is great for that. As I mentioned, I work for Amazon and Azure, so I'll just give a quick comparison. It's your preference at the end, but you can use, like in AWS, for example, they treat API gateway as separate service base. So each request, you need to create another API gateway, another API request connected to it. On Azure, for example, it's one solution. So you create a big solution and you configure all your APIs within that. API gateway on Amazon, there is no developer portal. On Azure, you get the developer portal. On AWS, it's only cloud-based, so the gateway itself will be deployed in the cloud. In Azure, you can deploy it in the cloud, or you can deploy it on-prem, but that's with an extra cost. Why the solution-based will be better? You can group all your APIs into products. So instead of selling or giving your APIs one API per one API, you can group that into products. You can apply those policies into products instead of applying each policy to each separate one. If you're using with like something like API gateway, you need to apply the policy for each API. And you can manage all the users and groups from the same pane of glass. And in that case, you will have users who belongs to groups. Both users and groups can subscribe to products, and each one of the product has multiple APIs that can be configured. Some APIs can share into multiple products, and some products can share multiple APIs. So it's seamless authentication and authorization, and that will be the flow at the end. Okay, any questions before I go to the last one? Yeah. Okay. I would say always, whenever you deploy your services, just use the one that you're already deploying there. Don't deploy your service in Azure and put your API management in AWS. That will be too much for latency. Okay, I know we're kind of on time. So just 3 takeaways here. Always secure your APIs. We just mentioned about the DDoS attacks. We mentioned about authentication, authorization. All these are layers to secure APIs. You don't need your APIs to be down at the end, especially when it's generating revenue for you. Don't reinvent the wheel. So if there is any, don't write your own code to do the authorization and authentication. Don't write your own code to do the caching. Don't write your own code to do the flow control. If there is a free service that can help you do that, just consume it. Keep your code for other things that are more business related. And always like expand your horizon. So I know most of us are developers, we just focus on our code, but take a step back, think what else you can use to help you with your code. Like we just spoke, again, I'll just take again the authorization and authentication thing. People think how to implement that, how to write the code for this, how to do it. You don't need to do that. Just take a step back. There is a service that can help you do that. Just relax. Focus on your business, core business value that you're providing. Okay. Any questions? before we get connected? Okay, I think I'm connected to some of you here already. I'll be happy to connect and keep connected with you. I'm here in Dallas, so you'll see me on the meetup from time to time. I also co-host the Kubernetes meetup here in Dallas. If anyone is interested, we'll be happy to just chat with me and let's see what we can do. Thank you, guys.